Okay, today we're going to look at all the different types of probability questions. And in this video I'm starting off with how to do the addition rule for probability. This example, and again I apologize for the clarity of this, I'm still working on some camera issues, but with this particular problem we have a table that gives age, and they're talking about responding to some kind of survey or if they refuse to respond. So this first row here are ones that responded. The second row, those that refuse to respond. Okay, this is age group 18 to 21, 22 to 29, 30 to 39, 40 to 49, 50 to 59, and 60 and over. Okay. Now the addition rule states basically two things. If the events are disjoint, or what we call mutually exclusive, which means you can't be both at the same time, then how you find the probability of A or B, remember the union symbol stands for or, is the probability of A plus the probability of B. If the two events are inclusive, okay, which means you can be both at the same time, then you find the probability of A or B by doing the probability of A plus the probability of B minus the probability of the intersection of A and B. So in this problem, what we're going to look at is the following example. It says, what is the probability, let's get these numbers here, what is the probability that the selected person refused to respond or is over 59 years of age? Alright, the key word here is the word or. That's how you know you're doing the addition principle. Okay, addition principle always goes along with the word or. Okay, you're selecting one person and you're looking at two different situations. Number one, whether they refuse to respond, or number two, if they're over 59 years of age. Now, this question really should read over 60 years of age because of the way the categories are set up. So we're just going to assume that's what they meant. It could have been a typo in the book. Okay, but we're going to look at the 60 and over age group. Okay, well, the question to ask is, can you be both a person who refused to respond and over 59 years of age at the same time? And the answer to that question is yes, you can. So because you can be both, then you have to use the second definition or formula for the addition rule, which is the probability of A plus the probability of B minus the intersection of the two. So this is how we're going to set it up. First thing we're going to do is we're going to add up all the people who refuse to respond. Okay, so I'm just going to take the calculator and I'm going to add these numbers up. I've got 73, 255, 245, 136, 138, and 202. And that gives me 1,049. I know you can't see those numbers, but I'll move them over in just a minute. Okay, and then the ones that refuse to respond are 11, 20, 33, 16, 27, and 49, which gives me 156, which means the total people in this survey is the 1,049 plus the 156, which gives me 1,205. That is your total sample space. When you're dealing with probability, this is your denominator. So I'm going to go back to my question. What is the probability that the selected person refused to respond? Well, again, I go to the refused to respond, which is 156, and I'm going to take that out of the total, which is 1,205. These are the ones that refuse to respond. Okay. Then I'm going to look at event, what we're going to call event B, which is over 59 years of age. Okay. Well, this time I'm going to come back up here, and like I said, I'm going to go with the 60 and over, probably a typo in the book, and I'm going to add 202 and 49. And that's going to give me 251. So as far as over 59 years of age, it's going to be 251 over 1205. Okay, then I have to subtract off the intersection, or basically where they both happen at the same time. Well, it's going to come from the category 60 and over. These are the ones that responded. These are the ones that refused to respond. So I want to know, how many do I have who are 16 over who refuse to respond? The answer is that 49. So that's what you're going to subtract off. If you don't subtract it off, you're basically adding it twice because you're including it in this group and you're also including it here. That's why you have to do that subtracting of the intersection. So if we do this, and probability, remember, is always a number between 0 and 1. So your numerator should always be smaller than your denominators, or else you're doing something wrong. And if you do this as a fraction, you're going to get 358 over 1205, which makes a lot more sense as an approximated decimal, which you're going to get 0.297 rounded to 3 significant digits. So the probability is 0.297, or almost 30%. Okay, that is how you use the addition rule for two events that are considered inclusive, which means you can be both at the same time. This particular rule is much easier if they're mutually exclusive, because then all you have to do is the first part, just the adding. So it's a little bit easier. You don't have to worry about finding where they overlap. I hope this clarifies the addition rule, and there's more to come in the next couple videos.